In this video, we're going to be taking a look at how to implement the SMS Startup AOI. This is for our Simplified Motion Series, or SMS actuators. The goal of this AOI is to overcome the initial startup sequence of these SMS motors. They use a single-turn absolute encoder, which is a great lower cost alternative to an absolute encoder, but for a linear motion, it requires a home move on the first power up. So for these motors, if you tell it to initially move out, it's going to perform a home move where it moves to the in position and then it will move out. And this kind of unwanted motion can be unexpected and possibly cause damage to your system. So to overcome this, we have a new startup AOI, which will perform this home move and also clear any recoverable errors so that when the done bit goes high, you can then move forward with any normal operation. First, let's take a look at the hardware. I have an Allen Bradley Compact Guard Logix PLC. I have a CPX API I/O module, where this is a Ethernet IP field bus module, and this is a I/O link master, and it also has an intelligent end plate here. And I have this connected to a EPCE SMS actuator. So EPCE is just one of the versions of this type of actuator, and this AOI will work with any version. Now let's take a look at the software. The expectation before this video is that you've already implemented one of the SMS AOIs. We have other videos explaining how to get to that point, but the baseline is that you already have one of the AOIs that's currently working, and this is a supplemental AOI to assist with your production. So right now you can see that I currently have an error, so I can reset the error, and I'm able to move out and move in. You might not have noticed, but at the very beginning of that move out command, there was a very quick move to reference the motor. So let's see this again. Here's a better look at how this initial sequence looks without this AOI. So right now this is after a power cycle, and when I tell the motor to move out, it performs this home move and then moves out. That kind of motion can be unexpected. So now let's implement the startup AOI to overcome that initially, so that when I tell it to move out, it's not going to perform a reference move, and instead it's just going to only move out, which is the intended motion. To do this, I'm first going to start by clearing all these bits so that I don't get unwanted motion. I'm going to go offline. Notice that I'm going to insert this at the I'm going to insert this AOI right before the existing AOI. This is because they're going to share the same message instruction, and therefore I don't want the original AOI to overwrite this while it's in use. Click and drag the new AOI in. Create an instance. Now let's take a look at the inputs and outputs here. Some of these have the same exact name as the original AOI's ones. So AB inputs and AB outputs. This is going to point to the module itself, so I can click and drag from the original AOI, copy these exactly. I have a connection faulted bit, which is the same as the original AOI. And now I have 4 AOIs that are going to relate to message instructions. Now, most of these SMS AOIs utilize this. Some of them do not. So if you're using an AOI that does not use the message instruction, then we'll have to create it based on documentation from that original library. So for now, I can click and drag these over. Now let's take a look at the new tags. I have an execute bit, which will manually start the sequence. Although I can also, there's a non-visible bit that I can tie to the first scan bit. So I'll show an example of using this here. So that's an example of how to start this. On first scan, it will perform this function. So it takes care of the execute bit. Use power relays. In this hardware example, I'm doing the most simplified approach, which is not using external relays to toggle the load and logic power on. Based on our manual, it defines that the load power should be turned on after the logic power by 50 milliseconds. So this provides the functionality that if you set this use power relays to 1, that it will drive some relay statuses or relay commands to then turn on external relays. And in the documentation, I explain exactly how to wire this in. But for this example, I'm not going to use a power relay. So I'll leave this as 0, and I will not tie my load and logic power relay statuses to the inputs that confirm that the relay has been closed. Now for this I home position, I have 3 options. I can set this to 1, 2, or 3, meaning 1 is that it ends the sequence in the in position, 2 ends in the intermediate position, and 3 ends in the end position. Either one of these work, it just defines your initial conditions. Now this I error code shows the errors that occur during the steps of the AOI. Although if you get an error in the message instruction, you'll need to look at the diagnostics in the message instruction itself, or if there's an IO link related error, you can observe that in one of the original AOIs. So this error code is strictly for the steps that occur in the AOI. So for this I home position, I'm going to leave this as 1, so I want to end it in the in position, like what's currently shown in the hardware. Right before we're ready to upload, I'm going to add in an interlock to the original AOI. And this is so that while the startup routine is running, I am not running one of the original AOIs. And I can simply use startup.xDone. So I have a done status that'll go true when the start sequence is finished and there's no errors, meaning that normal operation can begin. Now let's download this on the controller. Now technically this startup routine is going to run right away, but we're not going to see the intended motion yet. So let's first go to the original AOI. I am going to move this position out. After clearing the error. So now I'm going to perform a power cycle, and the expectation is that this is going to perform the initial move in and end in the in position. So let's bring up the hardware, and I'm going to perform a power cycle. So we saw that slow move in, and it ended in the in position. Now when I go back online, I'm going to see that the start is done, and now you can see, let's switch this back. Now that I have a done status here, I'm allowed to use the original AOI, where I can now tell this to move out after first recovering from an error, which is from the original communication loss. So this is how we implement the SMS startup AOI to overcome the initial startup sequence of the SMS motor and allow you to immediately perform normal operation.